Hey guys, I'm Shreyas, and today we are in the 8th day of the LeetCoding July challenge. And today the question is maximum length of repeated subarray. So they have given us two arrays, and we just have to find out the longest subarray which occurs in both the arrays. For example, over here, the longest subarray which occurs in both of these arrays is 321. The 321 occurs over here in the first array, and over here in the second array. So that the answer is 3 because the length of that is 3. So that's the question, and first we'll start with the brute force approach. So in the brute force approach, we'll try to determine if each position in the first array could be the starting position of the longest common subarray or not. So for each position, we'll try to brute force and check if it is the longest subarray or not. So the time complexity will be like O of m into n into minimum of m comma n. The reason for that is, like, for each of the positions we may have to traverse the entire remaining array to check if it's the longest or not, and to find the if corresponding element is there in the second array or not. So that also takes time. So it's like O of m into n into minimum of m comma n. So that is the brute force approach, and obviously it will not pass the time limit because it's like, in the worst case, it's like O of n cube, something like that. So now let's look at the more optimal solution for this one. So in this problem we'll be using dynamic programming for this question. So the intuition for using dynamic programming is, one is the constraints. So if you see, the constraint is quite low. It is like 10 power 3, so even an n square solution will pass, and hence it's an intuition like to use. Usually DP, we will be having two DP states if there are two arrays, so the DP approach will also be O of n square, and hence this is one intuition to use DP. And the other intuition to use DP is that if we compute the answer for some ith index of array 1 and jth index of array 2 and store it in, like, say, DP I comma j, and in the future if we again come across the same indices, we need not compute the answer for these indices once again. We can just take the stored values and continue with other indices. So that's one of the intuition to use DP. So yeah, so let's look at the code and more things will be clear. So this is the DP array. It's basically a 2D matrix, like n cross m matrix, and initializing all of that will be with 0. Answer will store the maximum answer for this problem. And over here, so basically what does DP of I comma j means? So DP of I comma j means what is the longest common subarray from the 0 till the ith position of array 1 and 0 till the jth position of array 2. So between those two ranges, what is the longest common subarray that's occurring? So that is the meaning of DP I comma j. And now we will be calculating the DP states only for those indices where the values are equal. So the reason for doing that I'll explain later, but we will only consider if the values are equal in those indices, and if they're equal, we'll update DP of I comma j equals 1 plus DP of I minus 1 comma j minus 1. So what it means is, suppose these are the two arrays, and say this is the ith position and this is the jth position, and over here, say we have some equal values like 2. So 2 and 2, they're equal, and hence DP of I comma j would be 1 plus. 1 plus is coming because these two are equal, and hence we are considering this value to be in the longest subarray. So that's why 1 plus comes. 1 plus DP of I minus 1 comma j minus 1. So the longest substring ending at the ith and jth position would be 1 plus the longest common substring ending at I minus 1 comma j minus 1th position. So whatever the longest substring we have formed in this range, that thing plus 1, so that will be dp of I comma j. And one more thing is, whatever substring is there in I minus 1 comma j minus 1, whatever the longest common substring is there in this range, it must end at the I minus 1th and the j minus 1th position only. The reason is that it cannot end at, it cannot be like, we cannot consider this as the longest common subarray of I minus 1 j minus 1. Say that is because we are computing the longest common subarray and not the longest common subsequence. So if it was the longest common subsequence, then for I minus 1 and j minus 1, the ending position could be anywhere. But since we are calculating the longest common subarray, it must be continuous, and hence for the I minus 1 and j minus 1th position, it must end at the I minus 1th and the j minus 1th position only. So like from the back it can go till anywhere, so but the ending position must be this. And now how do we ensure that for the I minus 1 and j minus 1 it ends at this? So that is ensured by this condition. So we are computing the states only if the indices, if the values at those indices are equal. So and hence we can ensure that the longest common subarray is formed and not the longest common subsequence. So for the same problem, if we change the question to longest common subsequence, then we'll be computing the dp states for all the indices, all pairs of indices, because we need the longest common subsequence, but not for this problem, because of this one reason, that it should end at this position. So and the answer can be like ending at any pair of indices, right? So we just update the answer at every possible dp state which we are computing, and just return the answer. So the time complexity for this approach is O of n into m, and even the space complexity is the same. If the problem was that of longest common subsequence, we can optimize the time complexity to O of n only, because there we are computing the dp state for all pairs of indices, and we just need the current and the previous columns at any given point of time. But over here we are not updating for all the pairs of indices, so here we can't do that optimization which we could have done in the longest common subsequence problem. So and the difficulty of the problem is like of medium level, which is just basic dynamic programming. And that's it for the video, guys. Thanks for watching.